Every time we look up at the night sky, we are looking back in time. The light from distant stars has traveled for thousands or even billions of years to reach us. But even then, we are only seeing part of the picture because there are two great barriers to our view. The first is swirling cosmic dust, which hides everything behind it. The second is the steady expansion of space itself, which stretches light beyond our visible spectrum and into the infrared. For centuries, these barriers have allowed the universe to keep its deepest secrets hidden. We've never seen the first galaxies or witnessed the earlier stages of stellar formation. But on Christmas Day 2021, all that changed. We finally launched the so-called Golden Eye that would allow us to lift these cosmic veils forever. The James Webb Space Telescope. A $10 billion three-agency collaboration, Webb is the most powerful observatory ever constructed. Equipped with ultra-sensitive infrared detectors, it's not only able to peer through the dust, it can see even the faintest and most distant objects. This telescope has revolutionized how we see our universe. We've seen wonders close to home, auroras on Jupiter, and the iconic pillars of creation, and those further afield, gravitational shockwaves and galactic collisions, to name a few. But Webb wasn't just created to send back pretty pictures. As of 2025, it has already completed more than 860 scientific programs and collected nearly 550 terabytes of data. That's more data than Hubble accumulated in 35 years. These datasets are revealing a universe far stranger and more complex than we ever imagined. I'm Alex McColgan, and you're watching Astrum. Join me today as we take a look at some of James Webb's most spectacular new images and unravel cosmic mysteries from across the depths of time. Becoming fully operational in July 2022, the James Webb Space Telescope was designed for one primary mission: to use its sensitive infrared detectors to pierce the cosmic dust clouds that permeate the universe, allowing us to observe the very first stars and galaxies. And it's off to a good start. Already some of its early findings are pushing the boundaries of what we thought we knew, challenging current models of how the universe has evolved. But to look that far back, James Webb has to peer through a lot of space. And along the way, it's made some remarkable discoveries around more familiar objects, ones that are only visible at infrared wavelengths. So let's take a trip across the cosmos and back through time, starting in our solar system and traveling to astonishingly distant early galaxies, all through the incredible eyes of Webb. Our first stop is in our own cosmic backyard, Neptune. Whilst it's usually easily recognizable thanks to its blue hue, with Webb it looks rather different. Doesn't it look ethereal? The methane in Neptune's atmosphere absorbs almost all of the infrared component of sunlight, meaning very little is reflected. There simply isn't much for the James Webb Space Telescope to pick up, making much of the planet appear dark. But this does have an upside. Instead, it allows the subtle, faint glow of Neptune's dusty rings and high-altitude clouds to stand out in dramatic detail. These are the clearest images we've ever taken. Not only beautiful, they've also revealed previously unseen ring arcs and shown us 14 of the ice giant's known moons. And this is just the start. Scientists are still poring over these images to uncover more of Neptune's secrets. I've already made a video on some of them if you want to find out more. But for now, the other secrets of the outer planets will have to wait, as Webb has been focusing its attention on one of the most compelling objects currently in our solar system, one that didn't start its life here. On the 6th of August 2025, Webb used its near-infrared spectrograph to join the fleet of telescopes and spacecraft observing the comet 3I Atlas. Its main focus was to analyze its composition. What Webb found has opened up a Pandora's box of possibilities. The comet turned out to be unusually rich in carbon dioxide and water vapor. In fact, the ratio was amongst the highest ever observed in any comet. It is a messenger from another star system, having formed in a region of its original star's planetary disk where temperatures were cold enough for CO2 ice to naturally freeze out. By directly sampling the comet, James Webb has proven that the basic building blocks of planetary systems and life are shared across the galaxy. The common elements and chemical processes that created our solar system are likely universal. But this extraordinary telescope hasn't just proven useful in exploring worlds in our cosmic backyard, it's also part of the hunt for new worlds beyond our star. And yet again, it's making some astonishing finds. Speaking of extraordinary telescopes making astonishing finds, have you ever wanted to get a little hands-on with that process yourself? Building your own James Webb Space Telescope will only set you back about $10 billion, but if you're looking for something a bit more affordable as you gaze into the cosmos, the sponsor of today's video, Dwarf Lab, can help. Dwarf Lab's range of telescopes are impressive, but I really love their Dwarf 3 model, a portable, smart telescope that's exceptionally easy to transport, set up, and use. Once I got it on its stand, it quickly oriented itself using the stars as its guide, so I could get straight into taking images like these. Using it was easy, just a tap was enough to get it working, and thanks to its stacking process built into the app, I was able to get great images in minutes without needing to do any later processing on my computer. The exploration doesn't stop when the sun comes up. It also features a gigapixel panorama mode that is great for the moon or other objects, taking 1 billion pixel photos during the day. You can even get a little bird watching in. So check out the Dwarf 3 for yourself. Scan this QR code or follow my link in the description below. If you use my code ASTROM5 at checkout, you can even get 5% off your purchase. The search for exoplanets is well underway. Thanks to missions like TESS, the Transiting Exoplanet Survey Satellite, and Hubble, we've already found more than 6,000 of them. But they've only been able to gather so much information. To find out more about these strange new worlds, they needed another instrument, and that came in the form of James Webb. It's found that our closest star has been keeping secrets. Just over 4 light-years away lies the Alpha Centauri system, a trio of stars that includes 2 Sun-like stars, Alpha Centauri A and B, and the red dwarf, Proxima Centauri. For decades, astronomers have suspected that planets might orbit the 2 Sun-like stars, but the immense, overlapping glare of the binary pair made them impossible to detect. Webb has overcome this obstacle, using its mid-infrared instrument and an internal chronograph to block the intense starlight. Much like you might use a car's visor to block direct sunlight so you can see on the road, this device stops the bright starlight and allows the faint light from the planets around it to be seen. This is an incredibly challenging observation, requiring meticulous image processing to subtract the residual light from both Alpha Centauri A and its companion star B. The resulting faint point of light, detected by MIRI, is now the closest ever exoplanet candidate to be directly imaged. It has given us strong evidence of a potential Saturn mass gas giant orbiting Alpha Centauri A. And even more surprisingly, based on orbital simulations, this gas giant likely follows an elliptical path within the star's habitable zone. While the gas giant itself would not likely host life as we know it, its existence confirms that a planetary system has formed around our nearest stellar neighbour, providing the potential for smaller, habitable moons or other terrestrial worlds yet to be discovered. Now, if planets and moons form throughout the universe, which we very much think is the case, the next question is, how? And this is once again something the James Webb Space Telescope can help answer. So let's continue our journey by diving into the immense, chaotic processes of creation. The cosmic cliffs, part of the Carina Nebula, 7,600 light-years away, and the iconic Pillars of Creation in the Eagle Nebula, 6,500 light-years away, may be familiar sights to some of you, thanks to the stunning visible light images captured by the Hubble Space Telescope. But Webb has given us an entirely different view. Rather than competing, Webb acts as Hubble's companion, using the infrared part of the light spectrum to peer through the thick, obscuring dust that Hubble's visible light can't penetrate. In this image of the Pillars of Creation, Webb's near-cam view reveals thousands of previously unseen stars, including newborns that were completely hidden within the dark, dusty columns in Hubble's images. They appear as bright red orbs lying outside one of the dusty pillars. Estimated to be just a few 100,000 years old, the red glow comes from energetic hydrogen molecules created in plasma jets and shock waves emanating from the new star within. It's as if the top of the pillar is pulsing with activity. Similar processes have also been seen as the cosmic cliffs. Here, Webb's NIRCam has captured crisp details of the turbulent gaseous structure at the edge of the nebula. This sharper look reveals that they are actively being sculpted and eroded by intense radiation from massive young stars just above them, a process much harder to visualize in Hubble's previous data. This new ability to peer inside these cosmic nurseries fundamentally changes our understanding of how stars and planets are born, finally allowing us to put theories based on simulations to the test. And what Webb is finding is that infant stars are not calm. Their births are explosive, energetic, and always spectacular. Deep in the outskirts of the Milky Way, in a region known as Sharpless 2284, approximately 15,000 light-years away, our golden eye found something extraordinary. A true behemoth of a protostar, weighing as much as 10 times the mass of our Sun. But not only that, this massive star is unleashing huge jets of gas and radiation. Known as a bipolar outflow, they are created as superheated gas falls inward toward the protostar's core and then is simultaneously blasted back into space. Powerful magnetic fields channel this material into narrow, high-velocity jets launched outward at hundreds of kilometers per second. Spanning 8 light-years, these spectacular birth announcement jets are nearly double the distance from our Sun to the Alpha Centauri system, and are immensely powerful, acting like a cosmic snowplow, pushing away the surrounding molecular cloud material and creating 2 much larger, opposing lobes of gas. This is a rare example of what's known as a hair-big Harrow object, bright patches of gas and dust that form when these jets collide with surrounding material. Although over 300 hair-big Harrow objects have been observed so far, these jets are particularly rare due to their immense size and strength. The stable, symmetrical nature of the outflow suggests the star is forming via an ordered disk, which provides crucial evidence for the core accretion model of massive star birth. What makes this discovery even more exciting is the fact that it's located in a star cluster on the far edge of the galaxy, where metallicity is extremely low. This means it has far fewer heavier elements than our Sun, and by heavier elements we mean anything beyond hydrogen and helium. This pristine environment almost perfectly mirrors the conditions of the early universe. By gazing through its infrared lens, Webb is giving scientists crucial clues to something that has long been a mystery: how the very first massive stars may have formed. But stellar birth isn't the only part of the creation process we don't fully understand. Planetary formation is equally mysterious, and yet again, something the James Webb Space Telescope is illuminating for us. Once a young star settles, the chaos around it begins to organize. The remaining swirling dust and gas becomes a protoplanetary disk, the birthplace of planets. As giant planets emerge within these disks, they can form miniature disks of their own. One example comes from the CT-CHA-b system, located 625 light-years away. This massive young exoplanet is encircled by a circumplanetary disk, a dense ring of material considered a moon assembly site. It's how we believe Jupiter's moon system formed long ago. Using its MIRI instrument, Webb delivered the first direct measurements of the chemical and physical properties of this potential moon-forming disk. Researchers discovered that the disk is carbon-rich, containing complex organic molecules like acetylene and benzene. This finding represents a major breakthrough, as this carbon-rich chemistry is in stark contrast to the disk surrounding the host star, where scientists detected water but virtually no carbon. This chemical difference, seen in a system that has only been evolving for 2 million years, allows us to compare the ingredients for forming moons in a distant system to the formation of our own solar system over 4 billion years ago. The universe is busy making worlds, and Webb is giving us an unprecedented front row seat. Now, we've seen how individual stars are born and how planets begin to take shape, but these stories don't happen in isolation. They play out across the vast, breathtaking structures of entire galaxies. In 2024, Webb focused on 19 nearby spiral galaxies, delivering images that are simply astounding. Forget the science for a moment and just look at them. If that isn't art, I don't know what is. You are looking at the heart of cosmic creation. In a galaxy like NGC 628, also known as the Phantom Galaxy or M74, located approximately 32 million light-years away, Webb's view is special because it highlights specific galactic ingredients. The blue light marks millions of older, established stars clustered in the galaxy cores, but it's the incredible red and orange that demands attention. This is glowing dust and gas, nursery material that threads through the spiral arms like fiery motorways. The bright red areas are stars that haven't fully formed yet, still encased within their dusty peaks. You can also see that the spiral arms are filled with giant spherical shells or bubbles, massive holes carved out by the shock waves from ancient exploded stars. Analyzing these consistent patterns across 19 galaxies helps scientists understand how they build, maintain, and distribute the material necessary for stars, planets, and with that, life. But even now, with all this information, we still don't have the full picture. We have one step further to go. Instead of looking at fully formed old galaxies, we need to know how and when they began. For that, we need to go back much further, to the very first stars and galaxies. It's time to travel back to the cosmic dawn, some 13.5 billion years ago. Even with the James Webb Space Telescope, with all of its spectacular technical advances, there are limits to what light can show us. The earliest light in the universe was released when space first became transparent, just a few 100,000 years after the Big Bang. Beyond that point, the universe cannot be observed with light. But luckily, physics gives us ways to see further than we otherwise could. Gravitational lensing. We see this effect when a galaxy cluster like RxJ 2129, located 3.2 billion light-years away, is in the James Webb's view. This cluster is so heavy that its gravity warps space-time, acting like a cosmic magnifying glass that bends and focuses the light from galaxies behind it. In 2023, Webb captured a distant supernova explosion behind RxJ 2129, but the telescope didn't just see it once. Its light was split, creating multiple images of the same event. Because the light from each image took a slightly different, magnified route around the cluster, the supernova appears as echoes across time. Analyzing the time delay between each one, or how much longer the light took along each path, allows astronomers to precisely measure vast cosmic distances. This data is critical for refining the expansion rate of the universe, also known as the Hubble constant. There's been some disagreement over this value in recent years. You can watch my video on it here. But who knows, maybe James Webb can help solve it with measurements like these. And so, we have arrived at the very edge of the observable universe, close to the dawn of time. Here, Webb's NIRCam and NIRSpec instruments, as part of the JADE survey, have pushed observation to its limit. The challenge is that light from the earliest galaxies is severely affected by the cosmological redshift phenomenon. This occurs because the expansion of the universe stretches light waves as they travel across vast distances of space, shifting the light from the visible spectrum all the way to the infrared, exactly the kind of light Webb is designed to capture. It has uncovered galaxies that existed far earlier and are far brighter than we expected, and one in particular stood out. Webb's NIRSpec instrument confirmed its redshift to be 14.32. This galaxy, now named JADE's GS-Z140, is seen as it existed only 300 million years after the Big Bang, making it one of the earliest known galaxies in the universe, beaten only by MOM Z14, which James Webb also spotted in May 2025 and is 10 million years older. The prevailing lambda cold dark matter cosmological model predicts that galaxies at this epoch, often referred to as the cosmic dawn, should be small, dim, and only just beginning to form their first, simplest stars, which is almost the opposite of this new discovery. JADE's GS-Z140 is too mature, too soon. To grow a galaxy this large only 300 million years after the Big Bang, the early universe must have been forming stars far faster and more efficiently than any current model allows. The very existence of this galaxy and several other similar sources forces astronomers to confront the possibility that the foundations of modern cosmology need a serious revision. One explanation for this contradiction revisits a bold idea first proposed in 2007 by cosmologists Catherine Fries, Paolo Gondolo, and Douglas Spoiler: the existence of dark stars. These hypothetical first stars are not powered by nuclear fusion like our Sun, but by the gravitational annihilation of dark matter particles within their cores. These potential first stars could grow enormous, millions of times the mass of the Sun, cool, and be long-lived, producing the infrared light Webb specializes in. So we could be looking at the signatures of dark stars. This fundamentally connects the most distant observations to the least understood component of our universe. So yes, the James Webb Space Telescope has literally shed light on our universe in a whole new way. It has revealed a cosmos richer and more complex than we ever dared to imagine. I am super excited to see what James Webb finds next, and with potentially more than 20 years of functionality still on the clock, there's surely a lot more to come. Which of those images did you like best? Let me know in the comments what you want James Webb to look at next. Thanks for watching. We mention this a lot, but that's only because it genuinely makes a difference. Astrum runs because of people like you who take a moment to join us in what we do. So consider taking 1 minute to look at the Astrum Patreon and see if any of the tiers and rewards interest you. Every member is core to our videos, and you get to watch all of these videos completely ad-free. We truly couldn't make these videos without you. If you enjoy what we do, come join the Astrum community today.